Astronomers have identified the brightest known object in the universe, one that had literally remained in plain sight for years. How was it possible that no one noticed it for so long? And what exactly is it? That's what today's material is about. In astronomy, we regularly encounter discoveries that go beyond our previous understanding of the cosmos. One of the most spectacular recent findings is the identification of the brightest object ever observed. It is the quasar J0529-4351, an object powered by a nearby supermassive black hole growing at a record-breaking rate. The results were published in the journal Nature Astronomy and caused significant excitement, especially since for decades it had been classified as an ordinary star. A quasar, short for quasi-stellar radio source, is a star-like source of intense electromagnetic radiation. Although it appears similar to a star from the outside, it is, in fact, an active galaxy with a supermassive black hole at its center. Matter falling toward the black hole forms a heated accretion disk that emits enormous amounts of energy. This radiation drives powerful winds that expel matter from the central regions of the galaxy at speeds reaching several percent of the speed of light. Quasars are often accompanied by jets, narrow streams of matter ejected along the black hole's rotational axis. Quasar J0529-4351 was studied in detail using the European Southern Observatory and its Very Large Telescope. It turns out that we observe it as it was more than 12 billion years ago. The supermassive black hole powering this object has a mass of about 17 billion suns and consumes matter equivalent to 1 solar mass per day. The result is a luminosity roughly 500 trillion times greater than that of our Sun. Why did such a bright object go unnoticed? In archival data from the 1980s, it already appeared as a point of light but was classified as a star. Modern sky surveys generate enormous amounts of data, analyzed in part by machine learning algorithms. If an object significantly deviates from known patterns, it may be misclassified. In this case, automated analysis of data from the Gaia satellite of the European Space Agency rejected it as being too bright to be a quasar. Additional observations were conducted at Australia's Siding Spring Observatory, and crucial data were provided by the X-shooter spectrograph mounted on the Very Large Telescope in Chile. Only the combination of more precise measurements made it possible to confirm the object's true nature. For comparison, in 2019, the Hubble Space Telescope recorded an exceptionally bright quasar, but its brightness was amplified by gravitational lensing. In the case of J0529-4351, no such amplification was detected. The history of quasar research dates back to 1963, when Martin Schmidt identified the radio source 3C273 as a distant, extraordinarily bright extragalactic object. Since then, advances in technology, both ground-based and space telescopes, have enabled the discovery of hundreds of thousands of similar objects. The discovery of J0529-4351 shows that even well-studied datasets may still hide groundbreaking objects. Progress in observational instruments and data analysis methods continues to reshape our understanding of the early universe. Subscribe if you would like to hear more content like this. See you in the next episode.